Hello and thank you for coming to my video today, guys. This is going to be a real quick video on the parts you need for a hardware stake pool for Cardano. We're going to be going over what IOHK recommends in their Cardano node guide, and then we're going to be talking about the choices that I made for mine. But just remember, this is subject to change, and then eventually stuff like a RockPi will be supported, but currently only Linux is supported. I'm sure you could do some tinkering and get it working, but I'm just talking about the build that I went with. And then just remember, some of this stuff subject to change. I also enabled ads on my channel, so if that's annoying to you guys, download Brave using my link down below, and then it'll give me some BAT to support me, or you guys can just tip that and then turn off my ads in general. I hate ads too, I understand it. One thing that you guys can do to support me, though, is stake to my pool. Even though we're not getting rewards right now, we will be soon. I'm sure everyone's going to keep their pool going. Also, another way is you guys can click this link down below. It's called Libri, and it'll take you to this site right here. What it is a decentralized YouTube. I'm going to have all my videos up on here. You guys can view my videos on here. For example, if you're watching my stake pool videos over and over and over again, it'd be cool for you guys to do that on here, because it actually pays me more than YouTube does, and it pays us both in cryptocurrency. And you can do this cool little thing called staking on here. And when you stake to somebody, you go down here and you click support, and it actually pushes my video up further, but you can always take your stake back, just like you can with Cardano. I'm just trying this app out a little bit. I'm trying to see how it goes and see if it'll bring just like new people to my channel. And also, I just like the idea of a decentralized YouTube where anyone can post anything that they want. That idea just reigns true to me with how YouTube kind of cracks down everyone's videos right now. But yep, that's it. I hope you guys enjoyed this video. Let me know what you guys think down below. Remember to share this, retweet this, and then turn the notifications on. I hope you guys have a wonderful day. I'm not only just going to talk about the requirements to run a node at your house, I'm also going to be showing off my node. And the reason I'm going to be doing that is just for my delegates. I thought it would be pretty cool to see what's actually paying you that ADA on mainnet, and what will continue to pay that ADA on the ITN if the ITN does live on, because I will be moving my pool on the ITN over to this. But hardware isn't what's most important, so I'm going to read to you guys actually what IOHK recommends for hardware, and then after I read that, then you guys can get a good understanding of like where I'm going to go with this. So they recommend an x86 host, AMD or Intel, a virtual machine or AWS instance with at least 2 cores. So we're going bare metal. So obviously we're not going to be running a virtual machine or an instance. So they say at least 2 cores, 4 gigabytes of RAM, and at least 10 gigabytes of free disk space. So I'm going to take that 10 gigabytes of free disk space and change that around a little bit. What I'm going to recommend for you guys is at least a 64 gigabyte SSD. This might not happen, but on the ITN, I was losing a lot of slot battles because of the latency of my hard drive. And that's what I'm going to be telling you guys is what matters most for these. The first is internet connection. And I don't mean speed, I mean latency. In the ITN, you were preferred in slot battles based on where your location was, and we're hoping that's fixed with mainnet. But also the second thing, past what location is, and this is going to be what's important for the Haskell testnet, is your latency, your internet. And it's really your ping, and it's going to be your ping to different parts. So it's very important. The best thing you can do for running a stake pool at home is have fiber connection, and that's not just for latency, that's also for downtime. Statistically, fiber connection goes down a lot less than normal broadband connection. It's fine to run your node on broadband connection, but a fiber connection is the best route. They also recommend a recent version of Linux, not Windows or Mac OS. This is going to change probably in a couple months when mainnet comes out, but where we are right now, you can only build your node on Linux, because if you run into any issues on Windows or Mac OS, it was not actually made for those operating systems, so we're not going to help you. There's not going to be a lot of people saying, hey man, I ran into that same issue, here's what the problem was. So right now only Linux is supported. And then they say make sure you're on a network that is not firewalled. In particular, be using TCP IP port 3000 and 3001 by default to establish connections to other nodes. And that's really about it. They recommend 2 cores, 4 gigabytes of RAM and at least 10 gigabytes of free disk space. And I went ahead and upgraded that to a 64 gigabyte SSD just due to latency, so your node can keep up with the blocks faster and download the blockchain faster. That helped me in the ITN. They don't recommend that. So if you want to get information from somewhere else, feel free to do that to verify what I'm claiming. But SSDs are pretty cheap now. It's not gonna break your budget to spend a little bit more. I'm pretty sure you could get a 64 gigabyte SSD for $40, maybe even cheaper. I mean, I got a 500 gigabyte M.2 SSD for $80. That's how cheap SSDs are now. But some people will try to be minimizing costs here so they can have a greater ROI, like the length of their ROI, how long it's going to take for them to get that return on investment. So that is important for me to mention that. And then as far as the 2 cores thing goes, I want to say you only need 2 cores, but I would say get a little bit more. A lot of you are going to be want to run your relay and your block producing node on the same server. For Jormungandr, the way it went is they recommended 1 core per node that you're running. So if you have multiple nodes running, they would recommend 4 cores, and that was mainly for stuff like Google Cloud or AWS. So they're recommending just 2 cores on here. This either could be because they have you set up a relay node and a regular node, but you're probably going to be run around 2 relays and then 1 block producing node. We're not really too sure if it's necessary to have it on a different hardware or not. So some people are saying that you need 2 different hardware or 2 different computers to run your relay nodes and your block producing nodes. We're actually not currently sure if that's true yet. If that is the case, what I'm actually personally going to do is run my relay nodes on a cloud instance and then run my block producing node at home and connect the block producing node to the relay node. If that's not the case, what I'm going to do is run my block producing node on my hardware at home and then connect that to the relay node that's also on my hardware at home, and then maybe have 1 or 2 more at different places on different instances. It all depends on what is the most optimal node that you can, the optimal configuration that you can have for this. And that's still to be determined. There's a lot of people arguing. If you ask different people, you'll get different information from both. And as far as this stuff goes, I'm just a parrot. I'm repeating to you guys exactly what I find out from other people. I'm not out there setting up 3 relay servers and checking how secure that is versus setting up 1 on my PC. And I thought it's important to be transparent for that. But what I'm going to do today is read you guys, like I did, IOHK's recommendations, throw some of my tidbits in there, and then also give you guys information on the conversation that's happening right now. And in the future, I am going to tell you, hey, this is what we figured out. But for right now, this is the necessary requirements. And then I'm also going to show you guys how I built my PC, or my server, I guess you could call it. And then why I made the choices I made on there. And I also found a lot of these parts just lying around my house from old PC builds, from building my friends' PCs, my girlfriend's PC, etc. I built a lot, so I've had a lot of parts lying around. So a lot of my parts I didn't really buy because, hey, this is exactly what you need. This is the cheapest price. I bought it because that's what I had lying around. Or not bought it, but that's what I used because that's what I had lying around. But yeah, we're going to go on to the next part of the video. Okay, so there are 2 routes you can go. You can either buy a pre-built PC or you can build your own PC. As far as pre-builts go, it's not really a bad alternative. A few years ago, when you're building your own PC, you're always getting the best deal because you're the one putting the work in. There was almost a cost to buying a pre-built, and that was the build cost. And then oftentimes you would get screwed out with a bad motherboard, or they would just have some shoddy motherboard, and the motherboard would have just shoddy components on it. But nowadays, it's actually sometimes cheaper to get a pre-built than it is to build your own PC. But you have to be careful, like I said, with them screwing you out a couple of the components. And what you can actually do is if you find a good PC for a good deal that meets all the requirements that I mentioned in this video, what you can actually do is just post that on Reddit or post that on my Discord and say, hey, what do you guys think of this PC? And I will always just say, oh, that's fine, blah, 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 blah. Just make sure you guys are checking it if you don't know much about computer parts. And then let's go the PC building route. So what do you actually need? I'm not going to be going over the keyboard or the monitor or the mouse in this because I think if you're wanting to build a node, you should already have those things. But what you're going to need is just like, I think 6 basic components off the top of my head, if 7 if you want to include the CPU cooler. So you're going to need a case. The case is not really that important. It just holds your PC. It's not going to improve your server at all. You just want something with a decent airflow. But like I said, you're not going to be doing any gaming or anything that's intensive on your hardware. So there's not going to be much heat in there. So you want a case that's cheap, but also has decent airflow. And by decent airflow, I mean like good airflow from the back as an outtake fan, maybe one, and then good airflow in the front. So a PC with good airflow will have like the whole front panel able to suck air in there, or have like some room for the whole front to suck air in there. And you can set up 2 or 3 fans right there just to give some air on the whole surface area of the motherboard. So then the next component we're going to be talking about is the motherboard. The motherboard's not really that important. You just want to get a decent, reliable motherboard. I like ASRock. They're usually pretty good and pretty cheap. But your motherboard has to match the processor. A good thing to do if you're not doing this online is to just go to a store called Micro Center, or a store like Micro Center. If you walk in there and say, hey man, this is what I want to do, this is my budget, they'll walk you around the whole store and let you pick out your parts individually. If you're doing this online, ordering it from somewhere, you can go to PCPartBuilder.com. You can build your whole PC out on there, have all the parts in order. And then if you're unsure if the parts that you had are good enough for this node, you can always send them in my Discord server, and we'll tell you, hey man, you're overkill, but that's fine, or you're underkill, whatever. We'll tell you in my Discord server. But what's cool about PC Part Builder is it actually tells you if you have a motherboard that doesn't work with the CPU, or the RAM doesn't work. And that'll bring us to our next topic. So the motherboard is like a little square board. I'm going to be showing it later in this video. Your CPU goes in there, your RAM goes in there, and your M.2 SSD goes in there, but I doubt you guys will be getting an M.2 unless you're flexing on me. But the RAM has to match the motherboard. And really, you pick your motherboard based on your CPU. So your CPU, you have 2 options. You have AMD and Intel. Right now, AMD is kind of killing it. So as far as processors go, I would check out AMD. A lot of their actual processors come with the CPU coolers, which is awesome. But you're going to, like I said, you're going to base your RAM off of the processor you pick, and it's probably going to be DDR4. That's the most recent RAM, and that's what all the most recent processors will have. And then another thing that we need to mention is the CPU cooler. Like I said, AMD is going to be is going to come with one. Some of them you just want to make sure first. They actually come with good coolers, but Intel does not. So you're not going to want to buy a CPU from Intel unless you're going to buy a third-party cooler with it. And then, so as far as coolers go, it's really not that important. You can get something that's real cheap. The nodes don't really run that hot, so it's not going to be too noisy. But if you, like I said, if you want to flex on me, you could get water cooling, which is just as easy of a setup as the other cooler, sometimes easier depending on where you buy it from. So as far as RAM goes, I know I'm skipping back and forth, but I'll make sure I touch on everything important. If I skip back and forth too much, I'm going to be reiterating on some of this later on in the video, so don't worry about it. I'm going to be showing it all off, what it looks like in person, but I'm just kind of giving you a rundown. So RAM, you can choose anywhere from 4 to 16 gigabytes. I really wouldn't recommend 4, but I also really wouldn't recommend 16 unless you just kind of want to future-proof yourself. I think 8 gigabytes is just fine to run 2 nodes in the same PC. 16 is definitely fine to run 3 to 4 nodes on the PC, maybe even more, because just because you have 2 nodes doesn't mean you're doubling the amount of power you need. Some people say that, but no, that's not the case. At least with most software and computing, if you just do double of something, it doesn't take double the power. So I wouldn't really recommend 16, but like I said, 16 gigabytes of RAM. I actually do have some laying right here. I got mine from Crucial. It's not really name brand at Micro Center. It's kind of their store brand, but 16 gigabytes was like $65. I mean, man, that's cheap as hell. I think 3 years ago, during the mining craze, RAM was like $200 for 16 gigabytes. And I think this is clocked in at like 3200 megahertz. The clock speed's 3200. I don't know if you call that megahertz or not. I think you do. I'm looking for the tag. I can't find it. And then as far as storage goes, I mentioned earlier in this video that you need to have an SSD, in my opinion. Some other people might have alternating opinions, and that's why before you do something that you're going to be running for a long time, you should get opinions from different people. I'm giving you my opinion. But what I went with was an SSD. I think you should have an SSD. I went with an M.2 SSD. Your motherboard has to support this if you want to go M.2. You don't need to. You just need to have an SSD in general. So there's two types of SSDs. There's an M.2 SSD. Your motherboard has to have a little slot for it, and you insert it sideways. It's kind of like you insert RAM, but instead it's on the side of the stick, and you insert it the side. More on that later. Or there's a SATA SSD. So SATA is what you use to connect your hard drives and your SSDs to your motherboard. By eliminating that SATA cable, you get a lot more read and write speed with this SSD. Like I said, this is a bit more future-proofing here. You never know what kind of stuff we're going to need for these Hydra channels and stuff, so I was like, screw it. $80 for 500 gigabytes, a little bit of future-proof, more overkill than Kaizen Crypto here. But yeah, that's really about it. Oh, a power supply. Can't forget about the power supply. So you need a power supply to supply power to your whole PC. Mainly your motherboard and your CPU. If you were installing a GPU, you would also need the power supply to supply power to your GPU. But we're not having one of those today. So your power supply, as far as how much you actually need, so they're rated, I think, in watts. So my PC is more than overkill. I'm actually using a power supply that I got for mining. I used to mine cryptocurrency back in the day, around 2017. I sold all my GPUs before it crashed, luckily. But that's why I'm using a 1200 power supply. But you want to get your power supply from a good company. This is really important. I recommend EVGA or Corsair, and I would get one of their better power supplies. But by better, I don't mean a higher number. I mean like they'll have like gold star rated or bronze rated or platinum rated. And then I would get like gold star rated or above. And then as far as the number goes, I would type that in on a calculator. I think PC Part Picker will actually have a calculator for you that you can use to type in how many watts do I need. You're probably going to need about 400 to 700. You might want to go a little over in case you want to add more parts in your computer. But PC Part Picker should tell you exactly the amount that you need. But I recommend getting a good brand and a good rating, a good star rating on your power supply. But yep, that's my rundown on the parts, and then I'll have a more interactive thing where I actually show you what the parts are and stuff. Sorry if this video isn't too useful to you guys. I thought it'd be pretty fun to make, and I do have a lot of knowledge on this stuff. So if you guys have any questions or anything I'm saying, remember, down below like always. But yep, we're going to go to the next part. It's more interactive. And then sorry if the... I don't mean to say sorry all the time. It's not like I actually like am apologizing. I'm just saying, hey, this is why I am doing this, you know? Because I get people, hey man, stop apologizing. I'm not like, oh, I'm so sorry. I'm just saying like, this is why I'm saying this, you know? But there is going to be, the reason I said sorry is because there's going to be a mic switch here. I'm switching from my Yeti to my phone mic, and that's just how it's going to be, because I'm not walking around with a Yeti. Okay, so the PC case I went with is the Carbide 275R. It was just on sale at Micro Center. It was pretty cheap. And then looking at it, the airflow isn't too bad from the front. They have this little hole so it can suck in air. And then also there's it came with this little filter for the fans up top to suck in more air, just to bring some more air in there. And then it also came with a fan in the back to pull it out. I wanted it because it's kind of small and minimalist. It's not my main PC. My main PC is sitting over there taken apart because I've been swapping parts back and forth between them. And then my cat's trying to pull my headphones down. But yeah, that's why I went with this case. Like I said earlier, my recommendation for you guys is just to pick something cheap that has good airflow. You're not going to have a big GPU in here. You're not going to be creating a lot of heat. So, I mean, you could even go with old cases that you have lying around your house. The case is not important. It just needs to fit your motherboard. So there's different types of motherboards. There's ATX and there's MATX, and then I think there's even one smaller than that. You just want to have a case that matches your motherboard, ATX or MATX or the smaller one. So I've decided to not make this a how to build a PC video and just show off the hardware that I chose and why I chose it. And then also just like kind of give you guys an idea on what hardware is actually required. There are many people that have made the how to build a PC videos. I mean, in my opinion, you obviously I don't think you need one. It's pretty self-explanatory. When you buy your motherboard, it'll have a little motherboard components list and it'll show you where each individual part goes. I mean, it's really simple, man. Kaizen Crypto actually just made a video on how to do it, and someone I would recommend is like Linus Tech Tips or Jay's 2 Cents. They both make good videos. So that right there is my M.2 SSD. It's a WD Black 500 gigabyte. You guys don't have to get one of those. Like I said, you could use the SATA ports over here, wherever they are, to do that. I think yeah, right here, SATA ports, and then. There's the 16 gigabytes of RAM that I chose. The reason I went so high is because it was only $64. And then as far as my CPU, I already have the cooler on there, so you guys aren't going to be able to see that. But I'm using the 7700K i7 from Intel. Again, it's overkill, but I actually already had this from a build that I did a long time ago. As far as the cooler goes, I spent about 30 or 40 bucks on it. It's a real simple Cooler Master cooler. The reason I got it is just because of how cheap it is. I'm not going to be doing any overclocking, and you shouldn't be either, because I mean there's no need for it with these nodes. I mean, the only reason to use water cooling would be to actually decrease the sound a little bit, but in my opinion, we're not going to be running too hot anyway, so it's not that big of a problem in the first place. I would recommend actually putting everything on your motherboard before putting it in the case. It makes it a little easier sometimes, but be careful in case you have a small case. Your cooler might not be able to fit in there right if you do that. And with the M.2, I still do need to screw that in right there, and then we're good to go. But yep, that is that, and then I'm going to show you guys what it looks like in the PC. This is what she looks like, all plugged in and ready to go. I really do like the minimalist look here. It's pretty interesting seeing a PC without a GPU in it. As a gamer, it's weird to see for sure. But everything's looking pretty good. I had fun building it. I like the minimalist design. I got to do some more wire management on the outside, but on the inside, the wire management looks pretty good in my opinion. It's kind of hard to see because of the glare, but I do like it. But I appreciate you guys coming to this video today. I'm going to be doing a live stream at 6 p.m. today. If you guys are watching this the day of release, you guys could make it to that if you have the time. I'm going to be trying to do some fun stuff, so I hope to see you guys there. I hope you enjoyed this video. If you made it to the end, type Cooler Master in the comment section. Have a good day.